So these El Nino events are pronounced year-to-year variations that we can have. Equatorial Pacific Ocean, also on larger spatial scales, not only equatorial, but but it's centered over the equatorial. So let's have a look at one of the bigger El Nino. Let's have a look at one of the bigger. So sea surface temperature is the clue, and before the event, there was an event that happened in 97, 98, famous El Nino event, but you can see the sea surface temperature distribution in the years before this event, and 1 year before, December 1996, here in the top level. Oops, where's the mouse? Is here. This is it. You can see a pronounced warm pool. Okay, this is the warm. Red means high temperature. You can see here exceeding 20 degrees. This is the warm pool. You can see where Australia is. Indeed, you can see the entire Pacific Ocean from 30 degrees south to 30 degrees north. What you also see is you can see upwelling along most of the equator. This is the equatorial upwelling. There's an equator. You can also see upwelling along the Californian upwelling system and the Peru, Chile. We'll talk more about upwelling in the second part. Okay? So now what happens during the El Nino is shown in December 1997, which is the panel B here on the left side. And you can see that the warm water pool has actually moved over and reached the entire eastern part. All right? It becomes more apparent if you actually look at the difference between panel B and panel A, which is shown in panel C. This is the sea surface temperature anomaly, the difference. So during or after the El Nino event, you can see that from sort of the center of the Pacific over to the eastern side, this area experiences a significant warming of up to 4 degrees Celsius. And it's not that warmer water is actually moved over these long distances, okay, which would not be possible. You can estimate how fast does a current have to be to move it. What actually creates these anomalies is a suppression of upwelling. If you suppress upwelling, which normally cools down the surface waters by, say, 2 to 3 to 4 degrees Celsius, if you stop that mechanism, then the surface water appears much warmer. And this is what happens. Okay, so starting after the El Nino event in 1997, he is shown here to the top, the sea level anomaly, and then another year later, the entire feature has turned to normal. It's gone. So that is what typically happens. These anomalies can stay for up to a year, but what the suppression of upwelling means is no more nutrients, no more phytoplankton production, no more. The entire food chain actually collapses, including everything that relies on fish, like seabirds, and indeed the entire fisheries of these are El Nino events.